Today we will start with the next big topic of the class that it's going to be the last big topic of the class that it's called factoring. Factoring, it's the reverse of the multiplication. So we have seen the special products. Factoring will be doing the opposite. From the answer of the special product, obtain the special product. So it consists of obtaining the factors from where the answer of the multiplication was obtained. So in this case, we will be using the reverse of the multiplication. So let's see. For understanding factoring, the first thing we need to know is what is the greatest common factor. The greatest common factor, it's for obtaining this one, or that it's also called the greatest common divisor between two or more numbers, we will use prime decomposition. If we remember, we have used prime decomposition of numbers to obtain the least common multiple or least common divisor also. In this case, it's going to be the similar process, but we are going to see we need to change how to obtain the answer. The process is the same, prime decomposition, but the answer will be a little different. So let's see. The first example says, find the greatest common factor of the next numbers, 8, 28, and 44. So to obtain the greatest common factor, we see we need to make prime decomposition. So remember, we need to decompose the numbers. So in this case, 2, 4, 14, and 22. In this case, when finding the greatest common factor, when a number divides every term, we will circle it or select it. We need to know that that number divides every term, because the greatest common factor, we are looking for those factors that divide every term. In this case, that number 2 divides every term. Then we need to use number 2. So that 2 also will divide every term, because it's 4 divided by 2, it's 2. 14 divided by 2 is 7. 22 divided by 2 is 11. Then we will use number 2, but this 2 doesn't divide every term, only divides the first one. Then we will use number 7. It only divides the second one. Then we will use 11. Only divides the last one. So the only common factors were number 2 and number 2. So to obtain the greatest common factor of numbers, we will multiply every term that divides, or every factor, that divides every term. So in this case, it's going to be 2 times 2. So it's going to be 4. So in this case, between those numbers, 8, 28, and 4, the greatest common factor or greatest common divisor, it's going to be number 4. So let's see another example. So let's see. In the second example, we will find the greatest common factor or greatest common divisor between 18, 36, and 108. So what we need to do is to do prime decomposition. So in this case, 18, 36, and 108. We will use prime numbers to decompose. Divided by 2, it will be 9, 18, and in this case, 54. So this one will be dividing every term, so it's a common factor. So then we can continue with number 2, and it's going to be 9, 9, and 27. So this number 2, it's not a common factor because only divides 2 terms, not the 3 of them. Then we will use these 3 that will divide every term, because it's going to be 3, 3, and 9. Again, we will divide by 3, and these 3 will be also dividing every term. So it's going to be 1, 1, and 3. Then you use number 3, but only divides the last one. So in this case, the greatest common factor will be composed by 2 times 3 times 3. That it's going to be 18. So the greatest common factor or greatest common divisor between these three numbers, 18, 36, and 108, it's going to be 18. In some cases, we can obtain the greatest common factor by mind. I mean, someone can see in this specific exercise that maybe 36 and 108 are divisible by 18. So that will be the greatest common factor. But when we don't know which is the common or the greatest common factor, we can use every time prime decomposition to obtain the greatest common factor. So let's see only one last example. So let's see, between 110, 33, and 66. So in this case, we will use prime decomposition to obtain the greatest common factor. So we start dividing by 2. It will be 33, it will be 33, and it will be 55. So this number 2 only divides the 66 and the 110, so it's not a common factor between the three terms. Then 33 can be divided by 3, so it's going to be 11, 11, and 55. In this case, 55 wasn't divisible by 3, so it's not a common divisor, so we need to continue. We can continue with number 5, so it's going to be 11, 11, and 11. So the number 5 only divides 55, so it's also not a common factor. Then we need to divide by 11. Of course, this 11 will divide every term. So in this case, the greatest common factor of these three numbers will be number 11. So as I was telling you, we can use every time prime decomposition to obtain the greatest common factor between two or more numbers. So let's continue with the topic. So after obtaining the greatest common factor of two or more numbers, we are going to see how to obtain the greatest common factor of an algebraic expression. In this case, we will start with monomial greatest common factor. So in this case, the greatest common factor of a polynomial will be the factor with the highest degree and the largest coefficient that it's a factor of each term of the polynomial. Maybe when we saw an example or an exercise, it will be kind of easier to understand this part. So the steps for obtaining the greatest common factor for algebraic expressions will be: first, we need to find the coefficient common factor. In this case, we will use prime decomposition as in the last example. Number 2, we need to find the highest common power on every variable. It must be on every variable to be a common power. The smallest value that a letter will have. I will explain that later. Then we will use the distributive property. That means we will put every term inside a parenthesis. And at the end, we will need to order our answers. So let's see some examples. So let's see. In the first example, we have something like this: 10 minus 15 plus 20 minus 5. So remember, we can obtain the coefficient common factor or the numerical common factor by using prime decomposition. So in this case, we can decompose every number in a prime decomposition. So we can do like a 10, 15, 20, and 5. So we can apply dividing by 2. So it's going to be 5, 15, 10, and 5. So we can continue with number 2. So it's going to be 5, 15, 5, and 5. Then we will continue with 3. So it's going to be 5, 5, 5, and 5. Finally, it will be dividing by 5. It's the only one that divides every term. It's going to be 1, 1, 1, and 1. So in this case, the greatest numerical common factor is going to be only 5. So we will put 5. Then we need to look for the letters. In this case, we need to look for those greatest letter or highest power of every letter. So in this case, on the first term we have x squared, on the second term we have x, on the third term we have x cubed, and on the last one we have x cubed. So the largest power that every term has, it's only x, because x squared, of course, that has x multiplied by x. X cubed, it's x multiplied by x multiplied by x, and x cubed, it's the same, x multiplied by x and multiplied by x. So every one of those have x as a common. Then with y, it will be something very similar. Here we have y, here we have y, here we have y squared. So y squared is composed of y multiplied by y, and here we have y. So the greatest or the biggest or the highest power that every term has, it's only y. So it's only y. Then we will need to use the distributed property. So we will open a parenthesis and we will see like if we have 5xy, how I can convert it to 10x squared y. So first, of course, we need to multiply it by 2, because 5 times 2 is 10. Then xy to become x squared y. So I need to multiply it by x, because if I multiply 5 by 2 is 10. If I multiply xy by x, it will be x squared y. Then we need to do the same with the other one. So the second one is going to be negative 3, because if I multiply 5 times minus 3, it will be minus 15. We have x and y. So in this case, we don't need to put letters, because it's going to be only multiplying 5xy by minus 3. We will obtain minus 15xy. Then it will be 20. So we need to put plus 4, because 5 times 4 is 20. With the letters, we have x. To become x cubed, we need to have x squared, because if we multiplied x squared and x, it will be x cubed. Then with y, we have y here and we need to become y squared. So we need another y. And finally, on the last one, to become minus 5, we need to multiply it by minus 1. We don't need to put the 1 as a coefficient in this case. The letters x to become x cubed, we need 2 of them, so it's going to be x squared. So y, we have y. To become y, we don't need anything, so that will be it. So that will be the end of the parentheses. Then we will need to order it, and it will be 5xy. Inside the parentheses, the first term will be minus x squared. Then it's going to be plus 4x squared y. Then it will be plus 2x minus 3. And this is going to be our correctly ordered answer. So it's not kind of difficult. It will be becoming very easy when doing many exercises. So let's see some other example. So let's see, we have this as the second example. So about ordering our answer, we can do two things. We can order the polynomial in the beginning, or we can do it at the end as we did in the last example. So in this case, I will order it first. So to be correctly ordered, we need to use descending order of powers and also the alphabetical order. So it's going to be minus 18 a to the 6 b squared. Then it's going to be plus 24 a to the 5 b cubed. Then it's going to be plus 12 a cubed b4 minus 42 a squared b cubed. So then we need to look for the greatest common factor between numbers. So it's going to be 18, 24, 12, and 42. So in this case, we start dividing by 2. So it's going to be 9, 12, 6, 21. Then we continue with number 2. So it's going to be 9, 6, 3, 21. Then we divide by 2. So it's going to be 9, 3, 3, 21. Then we divide by 3. So it's going to be 3, 1, 1, 7. Then with 3. Then with 7. So in this case, the greatest common numerical factor is going to be 2 times 3. That is going to be 6. Then, when having 6 as a common factor, then we will need to look for letters and powers. So we have a to the 6, a to the 5, a to the 3, and a squared. So in this case, between a, of course, a squared, that it's the smallest one, will be in every of the other ones because a cubed is from a squared multiplied by a. A to the 5, it's a squared multiplied by a cubed. A to the 6, it's a fourth multiplied by a squared. So that's what I was telling you. It will be the smallest number on the powers. It's the one that we are going to put. In the case of a, we have a squared, a cubed, a 5, and a 6. So in this case, the smallest one is a squared. That's going to be the common factor. In the case of b, we have b squared, b cubed, b4, and b cubed. So the smallest one is b squared. So it's going to be 6ab squared. So then I use the distributive property, or I open the parentheses. So let's see. When we got minus 18a to the 6b squared, so 6 to become minus 18, so I need to multiply it by minus 3. Yes? In the case of letters, a squared to become a to the 6, so we need other 4 of them. So it's going to be a to the 4. In the case of we have b squared, we have b squared, so that we don't need anything. So let's go with the second one. 24, 6 to become 24, it's going to be plus 4, because 6 times 4, it's 24. Then go with the letters. A squared to become a to the 5th, we need 3 of them, so it's going to be a cubed. Then with b, we have b squared. We need to become b cubed, so we need only a b. On the third one, 6 to become 12, we need plus 2. On the letters, a squared to become a cubed, we need only one a. B squared to become b to the 4th, we need 2 b's. And on the last one, minus, it's going to be, in this case, 6 to become minus 42. Then 6 times 7, it's 42. In the case of the letters, a squared to become a squared, we don't need anything. B squared to become b cubed, we need a b. And this is going to be the actual monomial common factor, and the way to factorize or factor that part. In this case, because this specific polynomial starts with a negative one, because we must look that many times starting with a negative can be a little bit of trouble, we can, or we will try that the first term inside the parentheses needs to be a positive one. So in this case, we can put it like, we can take out the minus sign of the parentheses. So all of the terms inside the parentheses will change sign. Not to have the first term inside the parentheses as a negative one. So this is going to be our answer, that it's correctly ordered and without having a negative sign in the first term in the parentheses. The polynomial that it's inside the parentheses cannot have negative as the first term. So let's see only one last example. So let's see, in this example number 3, I will be doing it a little faster because I think you have understand the basic parts. So we can order our polynomial in the beginning and we can put it like in this case minus 48 x to the 7 y to the 4. Then we will have plus 16 x squared y x5, I'm sorry, x to the 5 y squared. Then we will have plus 24 x squared y cubed minus 8x squared y. So we need to do prime decomposition of the numbers, or we can also do it by mind. In this case, 8 multiplied by 3 is 24. So all of them is 8 multiplied by 2 it's 16. 8 multiplied by 6 it's 48. All of them are divisible by 8. So I can do it by mind, and I can know that 8 is going to be the largest or the greatest common factor between the numbers. So I can do it in one simple step, 8. Then we will look for the biggest powers that it's common. So x to the 7, x to the 5, x squared, and x squared. Remember, when we have letters, it will be the smallest one also. So in this case, it's going to be x squared. In the case of letters, y to the 4th, y squared, y to the 3rd, and only y. So it's only going to be y, because y cubed, of course, have y squared, of course, have y, and y to the 4th, of course, have y. But y cubed, I mean y doesn't have y cubed, so it's going to be the smallest one, y. I will open the parentheses to use the distributed property, and let's see, 8 to become minus 48, it's going to be minus 6. Then x squared to become x to the 7, we need 5 of them. Y to become y to the 4th, we need 3 of them. Then it's going to be plus 8 to become 16, it's 2. X squared to become x to the 5, we need 3 of them, so it's going to be x cubed. Y to become y squared, we only need 1, y. 8 to become 24, so it's going to be t times 3. X squared to become x squared, we don't need anything. Y to become y cubed, we will need y squared. And finally, 8x squared y to become minus 8x squared y, we need to multiply it by minus 1. In this case, of course, I need to put this minus 1 because it doesn't have letters. So coefficient number 1, we only put it where it is only the number, not letters. So here, we have finished this one, but in this case, remember, we don't want to have a negative sign on the first term inside the parentheses, so we can, this minus sign, we can take it out, but all of them inside the parentheses will change sign, so it's going to be minus 8x squared y that multiplies 6x to the 5 y cubed minus 2x cubed y minus 3y squared plus 1. And this is going to be our actual final and ordered answer without a negative sign on the first term in the parentheses. So that will be it for today. We will continue with greatest common factor for algebraic expressions monomial tomorrow.